morning. My name is Zheng Yu, metric number 206634. This is our presentation outline, and I'll be presenting the introduction, project improvement recommendation, and the conclusion. First, we will go with the introduction. And our project main topic is the buoyancy. I will now introduce buoyancy. Buoyancy is a force pushing upwards against the gravitational force. It will exist when a solid body is submerged in a fluid. When there is a buoyant force, the solid body immersed in the fluid will weigh less than when weighed in the free space. Therefore, an object will float when the buoyant force is greater than the weight of the object. And although the object sinks, it will also lose a part of the weight. Buoyant force is said to be explained by Archimedes' principle, which applies on fluid, which will be explained in the conceptual part. And now this is the project that we are going to run out, which is the emergency flotation system. It utilizes the buoyancy principle. Emergency flotation system is utilized on a helicopter to maximize the chances of surviving when the helicopter is involved in either a controlled ditching or a water impact sinks. An EFS has floats that are packed within spaces inside the airframe or fitted as externally mounted packs on the lower structure. While the floats applies Archimedes' principle, which displays a volume of water to create enough buoyancy to lift up the helicopter when a helicopter crashes in a water surface. And rapid inflation of the floats is important to ensure, and the work is ensured by the helium gas stored in the pressurized cylinders. Rapid inflation is important, which it guarantees the helicopter in safety before an impact against the water surface.
My name is Nurin Binti Hamid, and matrix number is 207071. In this project, I'll be presenting the literature finding parts. So I'll begin now. So the physical law of buoyancy is Archimedes' principle. So this Archimedes' principle was discovered by the ancient Greek mathematician and scientist named Archimedes. So Archimedes states that the buoyancy force on any object which completely or partially immersed in a fluid is equal to the weight of the fluid displaced by the object. So this principle explains why an object sinks or floats. Just a simple imagination, like we saw a boy on a swimming pool. So this principle would explain why the boy sinks or floats. So this principle also requires domain-specific knowledge regarding the concepts of density, force, gravity, mass, weight, and also buoyancy. So buoyancy is a common and directly observable and applicable science phenomenon. This object floats at rest because the upward force of buoyancy is equal to the downward force of the gravity. So next, I'll be talking about the emergency flotation systems. So emergency flotation systems, EFS, are designed to keep the helicopter upright for enough time to allow egress from the helicopter after a ditching. While there would be virtually no design possible that could mitigate against all rollover events, a properly executed landing onto a favorable sea state should give the passengers and crew sufficient time to retrieve vital survival equipment and safely egress the helicopter into the life rafts. The helicopter suffers from water rapidly filling up and sinking nose down due to the buoyancy force in the forward end, which is an additional hazard when the aircraft rolls over. These flotation systems have physical limitations in that they are only rated to perform on a given certain aircraft weights, sea states, and other factors. The reasons for these limitations are mostly self-evident, but relate to the ability of the EFS to provide its rated performance in the event of a ditching. This is why the emergency flotation systems are designed, which is to keep the helicopter upright for enough time to allow egress from the helicopter after ditching. Thank you.
Assalamualaikum to Doctor. My name is Nurin Umyrah Binti Zaharudin with metric number 207342. Now I will explaining this part which is conceptual of the system. So, what is buoyancy? The Greek mathematician Archimedes expressed that the buoyancy force acting on a body of uniform density immersed in a fluid is equal to the weight of the fluid displaced by the body, and it acts outward through the center of the displaced volume. The buoyancy force equation above is used to determine force acting on the object from inside the water. In general, the buoyancy force equation on a completely submerged object of volume is buoyancy force equal to V rho G. In this study, we can calculate the buoyancy force acting below the helicopter. As you know, only small part of the helicopter body will make contact with the water, so we need to calculate the volume of that part only. The volume that sinks a small part of the object is the ratio of the volume submerged to the volume of the object. The buoyancy force it depends on the shape of the object, only on its volume and the density of the fluid. Buoyancy force is directly proportional to the density of the fluid in which an object is immersed. There are three requirements for floating, which are: first, the buoyancy force of the flotation device should be able to keep the helicopter afloat during emergency water ditching. Therefore, fluid buoyancy force is bigger than the weight of the helicopter. Second, constructed using the lightest materials possible as well as maintaining the strength required. Third, long operation time before failure and less maintenance routine. For the floating device ideas, there consist four points, which is inflatable flotation bag, inflation device and system, flotation mount and bag cover, and lastly is controls. For inflatable flotation bag, the number of fluid needs is 2, which attach on the right and the left of the skid, and it's designed for stability up to sea state 6. In addition, the stability of the buoyancy is depending on the center of the gravity, whereas the center of gravity must be near the center of buoyancy. The second, for inflation device and system, the fluid are configured as skid mount system and it depends on landing gear configuration. The inflation use helium blended with nitrogen since the helium is a very light gas, as this will increase the buoyancy of the helicopter. Third, flotation mount and back cover. The emergency fluid stood enclosed inside back cover is in order to protect the fluid. Must produce nose up attitude, and lastly, the back cover must made of waterproof materials such as nylon. For number 4, according to FAA, which is Federal Aviation Administration, there are 2 steps to activate the flotation system. First, inflation circuit must be armed before landing. It's necessary to prevent accidental fluid activation. Second, inflation triggered by water contact sensor. The system will activate when 2 of 4 water sensor make contact with the water. But a manual backup handle will provided, but cannot be activated until after a collision because the helicopter may be out of control.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal bin Muhammad Sabar, metric number 207152, and this is my task doing the technical drawing of the model. So for this part, I use CATIA V5 R21, which used to sketch the helicopter with the floating device. The dimension that I use is centimeter, which is actually it is suitable for the model. I have drawn 3 models actually. 2 drawings, which is before the fluid inflate and after the fluid inflate, and also I drawn the additional improvement, which is a new design, which use tri-bag floating system. So let's go. This is the sketching for before inflate, which as you can see there is a container, which contain inside there the fluid, which is not activated yet. So this is the how the device will be looked. Next, we go to after inflate. Okay, this is after inflate, which if the float activated, the air in the back will pump in, and then it will become just like a banana boat shape, but not too big like a banana boat, but it just the shape is same but a bit smaller, which is suitable for the helicopter. So this is the float that help helicopter to float on water surface. Okay, now I will go on to the float design improvement, which by using tri-bed float system as the main flotation system, it will increase the value of buoyant force. If the value of buoyant force increases, that means the bigger the load it can support, which means many things many humans can be in the helicopter, which when it was floating on the water. Next, the surface area will increase, which means increased stability of the object and also reduce pressure on water surface. This is also good, which it will remain stable on the water and will not topple down. So that is the safety aspect that used in our improvement. So let's see the design. So this is the design of the helicopter with tri-bed float system. Okay, as you can see, there is three float that attach to each other, which gives more buoyant force that can load more 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 load, which can support more load and also give stability. So that's all from me. Thank you very much.
Assalamualaikum and a very good day to Dr. Azmin. My name is Abdullah Hannan bin Shamsudin. My matrix number is 207297 and I will be presenting the results and discussion for this project. So the calculation for this project will be referred to a real H130 Airbus helicopter. So this is important because we need to obtain the maximum takeoff weight with external load that will be applied to the calculation. So the model of the helicopter has been chosen due to its multi-purpose in tourism, medical, transportation, military, and surveillance services. So as you can see on the right side of the slide, there is a real helicopter H130 Airbus. And the downside of the slide, you can see that a stretcher that is going to be inserted into the aircraft. So this is very, very important that we provide an emergency flotation device for better passenger and pilot safety. So the result from both design of the float will be compared to obtain the best buoyancy support and stability suitable for this particular helicopter. All right, so before we moving on to the buoyancy calculation for each float, we need to obtain the volume for each design of the float. So the float one volume, the dimension is 0.5, which is the radius, 0.5 meter, and the height or length is 2 meter. So the volume is 1.57 meter cube for each. Since the float will be installed onto the helicopter, there will be 2 floats total. So the volume becomes 3.142 meter cube. On the other side, the float to volume, the dimension of the radius has been reduced to 0.4 meter, and the height or the length of the float are still maintained to 2 meters. So the volume is 1.01 meter cube for each of the float. And after that, because there will be 3 floats that will be installed onto the aircraft on each side, making total 6 floats. So the volume become 6.06 meter cube. So once we have the volume of the float, now we can calculate the buoyancy force. But before that, the Airbus H130 MTOW with external load is 3,050 kilogram, which is equivalent to 29,890 Newton of weight. So after that, the float one buoyancy force can be calculated, and the buoyancy force for float one is 30,999.2 Newton. So this value is not really a major difference between the helicopter weight and the buoyancy force. So this number is not convincing enough to make sure that the aircraft can stay afloat onto the water for a longer time or longer period. So on the other side, the float to buoyancy force, so we can see the buoyancy force is 59,209.1 Newton. So as we can see, the number is very convincing because it's almost double the weight of the aircraft itself. So the superiority in buoyancy force compared to aircraft weight and improved stability due to the larger surface area of tri-back design of the float 2. So the float 2 has been chosen as the perfect design for this project. So that's all from me. Thank you.
Next, I'll be continue with the recommendation for improvement of the project. Every project has its pros and cons, then we have to solve the cons. And to ensure the safety of occupants on the helicopter, the inflation time should be as shorter as it can. So thus make the impact between the helicopter and the surface of water is buffered by the floats. And due to the inflation of the floats, apply the principle of pressure. The problem of pressure built up lag because of small warm-up gas. Thus, aspirated system should be tested out in next investigation, because aspirated system is a lighter weight system which not burden the weight of the helicopter. And to avoid tears and leaks on the floats, which would cause it cannot withstand the weight of the helicopter, tough and elastic materials should be used for building the floats to bear the impact when the helicopter lands on the surface of water. And to ensure the flotation system can withstand the weight and impact of helicopter, a tri-back flotation system is utilized instead of just one flotation system. Because using a tri-back float system, it will increase the value of buoyant force. And now I'll be going to the conclusion. Buoyancy is an important principle utilized in every matter relating to floating. Thus, we know that emergency flotation system is functioning with buoyant force and ensuring the safety of occupants on helicopter, saving them from accidents. And in our project, we create a flotation system which is a smaller scale, which can show the same function as the EFS, but the things that we create, it cannot use on a real helicopter. So maybe we can try it on drones to save drones when it falls from uncontrolled situation, and the drone will be protected from damage. From the research throughout buoyancy and emergency flotation system, contribution on environmental issue can be found, which prevention of crashes and explosion of helicopter, ensure there is no pollutants such as fuels, pieces of helicopter sink to the bottom of the seabed, which is kind of polluting the sea environment. Besides that, prevention of wastage is also can be done, which contributes in saving the energy and sources of Mother Nature. In a nutshell, this project not only provides opportunity for occupants on a helicopter to survive in accidents, but also prevent solution and saving sources on Mother Nature. And I think this is the end of our presentation of this project. Thank you.